Alright, welcome back to another Advent of Code session, and today we are gonna solve day 15, Warehouse Woes. And yeah, I mean it's a ICS keyword lanternfish. I remember from like, oh shit, 3 years ago. Damn. Okay, anyways, so we are on some submarines and we are trying to search for the chief as usual, as we got used to this year. And we are trying to help the lanternfish from 3 years ago. And they need a lot of food. That's the main problem because they grow rapidly, if you remember. And they lost control over one of their robot that controls some warehouse. And how this robot works is that it can push boxes around and it is programmed to move based on a certain set of moves. So it has like some moves and it's gonna follow them regardless of what happens. So what do we have to do is to predict how the map will look like after the robot does its moves. So the lanternfish are helpful enough to give us the puzzle input, or I guess, no, the map. So this is the map of the warehouse and these are the moves. And the circles, the O's on the map represent the boxes. The @ symbol is the robot, and this robot will move based on these moves and push boxes around. And what's cool about this one is that if you have like a stack of boxes, it pushes all of them. It doesn't have a limit. Maybe it's gonna, like, part 2 is gonna add a limit or something of how many boxes it can push, but we'll see. So yeah, basically it can push around multiple boxes at once, and the goal is to find the final configuration of the map. So for instance, after all the moves are done, we get to this configuration, and we get the GPS coordinates and do some math on the coordinates to get the answer. So for instance, we do 100 times row plus column, and that's the GPS coordinate of a single box, and we add all of them together to get the final result. So I mean, it sounds kind of straightforward. I don't really see any issues with it. So I was thinking, okay, I guess let's do this one in C maybe. Why not? Let's try to do it in C. Okay, so let's create a main.c file and let's include std.io.h, and yeah, basically, I mean, we can also download the file, like the puzzle input, and start with parsing the input, I guess. So yeah. So what I want to use is basically ds.h. I misspelled my username. So ds.h, and this just adds small data structures like link, I guess not linked list, but dynamic arrays, being able to read like from a file and stuff like that. So that would be kind of useful, I would say. So we are gonna include ds.h and define ds implementation. I think we'll start with IO only. So we can do something like ds IO read. And I don't really remember if you pass null as the file name, it reads from standard input. So we can pass null and we'll read the file input. Right, so we can do something like read. Oh, and obviously our the first stuff Okay, so here we pass in null for the file name, then we have a char pointer buffer, which is gonna be also null, right? And we send the reference to it, and then the mode is gonna be read, like here I was doing this as, you can say, read binary or read, but so if this thing is not equal to this, okay, I think I have something like this, yeah, then we return defer 1, so like an error. Okay, perfect. And then we can just printf this this thing. I can also put like some characters around it so we can see where it starts and where it ends, but that's just, yeah. And then we can pass in tmp into it. So this dynamic array free, maybe it's, oh, wait, what? DSIO implementation, like, am I did I do something weird? DSSB, wait, what? Oopsie doopsie. Wait, I'm not sure what happened. Let me just clang it and see if it gives the same error. Wait, what? Okay, anyway, let's go into the Linux. I mean, I thought I have something. I'll just add clang as a, you know what, let's just close that. It's weird, I'm not sure why it throws that errors, because I thought I defined the shit. What? Dang, I don't know how I opened that stuff. So if we go to D15 and try to use clang, oh shit, it doesn't like that. DS dynamic array init allocator. But it's weird, because if I define this, maybe I didn't write this one properly. Like, I thought that if, oh, yeah, maybe the order of my defines is not correct, but whoops. Anyway, huh, interesting. So if I echo something into main, it fails for some reason. Okay, what the fuck? But it's why does it fail? That's really interesting. I think I always used clang for this one, but fuck? So this I already, oh, I think I'm stupid. It returns the number of bytes. I think it returns a negative number if it fails though, but yeah. So if this thing is less or equal to 0, then it should fail. Yeah, I don't know why. Anyway, so it reads the input. Okay, perfect. So the next step would be to parse this input, and I think the easiest way to do that is to maybe have a structure for the input. So let's type the structure, and it's gonna be, call it puzzle, why not? And what do I want to have here is a list of all the walls, all the boxes, the position of the player, maybe the width and the height, although I'm not sure if that's needed, but yeah. So, and we are going to use dynamic arrays for those things because why not? So it's going to be walls, this dynamic array boxes, and I guess type def struct, we are going to have int row, int column for the vec2, let's call it. So this is going to be an array of vec2, same as this one, and then we're going to have a vec2 player, or I guess, you know, it's the robot, but it's like the player. And I think that should be all. Oh yeah, another one will be moves, and the moves are gonna be, maybe we can just map them to delta, like, if you know what I mean. Let's put them like that. So they're gonna be just 1 0 0 1 minus 1 0 and 0 minus 1. Okay, so then we can have a function. Let's do it like static void parse input, and what this thing is gonna do is I mean, this is better to use it like int buffer length, like this. Alright, we'll see what's the arguments and stuff there, but that's so. And if the buffer length is too small, then it's basically over. And in here I can do stuff like if buffer is not null, then we can free it. Doesn't matter why we pass a null there. Okay, but it's like, I don't really care about doing it like memory safe and freeing all the memory. So what we can build here is a slice. So this what this string slice, and this is gonna be like input, and we can say string slice init, input, and then we pass in the buffer and buffer len. So we create a string slice, and now we can say that our parse input function is going to take in a string slice, it's going to be the slice, and a pointer to a puzzle. So we are going to pass, we are going to do something like puzzle is equal to 0. Maybe we can even have an init function like static void puzzle init, right? And we just initialize the dynamic arrays. really is like in C you have to write a lot of code, you know, and I think that's the main issue maybe with it. Not sure, but I'd say it's like because you have to write a lot of code, it makes it easier to follow because it takes longer to implement something, you know what I mean? So it's like, okay, I have time to think about what happens. So anyway, just the idea. So then here we have puzzle. The robot coordinates are gonna be probably 0, 0, so I can just do something like wait. I thought it works to have like column is equal to, or I guess row is 0, column is 0. So initially, so that's how we initialize our puzzle. Okay, I don't think we need width and height, probably. I mean, hopefully it's not gonna say something like, okay, let's remove the walls and whoops. All right, so, but I mean, we can just add width and height afterwards if is needed, so perfect. So what do we have to do with our, so if we look at the input, we have to split it by double new line here. That's something slice. I mean, first of all, let's trim left, or I guess trim in general. We trim our slice with white space basically. Yeah, so I mean this one can fail, but oh, you know what, I have unreachable, like I remember, if you remember from the compiler stuff, we added a lot of like kind of useless macros just for these kind of things. So like this function returns status code, but it cannot, like, come on, cannot fail. It just needs to increment an index. So that's how we trim the new line at the end, because let's not forget about that one. And then I need to string slice. I think I have a tokenize. So how tokenize works is kind of similar to strtalk. So you put here a delimiter, which sadly has to be only a character. So we are gonna have to work with it like that. And here we are gonna have a line. So yeah. And how tokenize works is it returns 0 if a token was found and 1 if the string slice is empty or we reached the end. Okay, so that's the idea. Okay, and we need to define this string slice for the line. Say 0. And the idea is while this thing is 0, we can split it by lines. So here we get all the lines, right? And what we can do is first parse the map, right? And something like if ds string slice equals, or I guess I have starts with, but let's do equals. So if our line is equal to, and I can just define here, define new line slice is just this string slice Oh, I mean, I thought I have something like this, which just computes the string slice. Like I can say yes string slice and I pass it \n and it gives me the thing, right? Oh, I guess it needs reference, but that's not important. And this one returns a boolean, so returns true if they are equal, right? So if we found a new line, then we can do a break, right? It means that we found a new line, and then parse the moves, right? And we do the second while loop, that's the same thing, except this time we go until the end. So see, you don't really need split by a string, you can do it like this as well. Okay, so let's do first the moves, because the moves are gonna be the easier ones, I guess. So I can have something like static vector parse move, and this thing is gonna take in a single character for the move, and we are gonna generate the delta for it. So I can do something like if move is equal to, let's say, less than character, then we are gonna return vec2, and we can say that, well, the row is 0 and the column is -1, right? We move in that direction. Then else if move is equal to right, then we are gonna do +1. And the last two cases are gonna be like this character and v. So if we move up, we are gonna do -1, because usually up is -1 and down is +1, but you can do it the other way around if you are weird, but yeah. And on the else case we have the Hispanic not move, right? So here let's do string slice trim. Let's trim our line first, so we get rid of the new line at the end. Again, the new line at the end. I guess there won't be any new line at the end because we used tokenize, but who knows? Maybe like weird stuff can happen. So this unreachable, this is just to handle all the errors. Okay, so interesting. Now we have the string size for the line. I don't think we have, I mean, we have a step function, we have stuff like that, but we don't really have like we can convert it to a like char pointer, but I don't want to do that. What do I want to do is to just have a for loop and do something like for unsigned int I is equal to 0, I is less than line dot length I plus plus. You can do something like parse move line dot str I, and this is gonna give us vec2 move, right? So this is gonna parse a move, and then we can do something like this dynamic array append, and here we are gonna append the move to the list of moves in our puzzle. So hopefully that's gonna make sense. So we do puzzle moves, and we pass in the move here. And I have another macro, usually this one, like ds error. There was like a, oops, yeah, I shouldn't see that. Okay, so if you know, this one fails, then it's an out of memory issue, so we can display something relevant instead of unreachable. Anyway, so we just append our move to the list of moves, right? That's good enough. And the move is already gonna be like a delta, so perfect. Okay, nice. So here we parse the moves, and here we need to parse the map, which is just the list of walls and the boxes. So let's do the following here. Let's have an int for the current row, which is going to be 0. And at the end of this, we are going to increment it by 1. Right. And you guessed it, we can just use the same for loop, but I want to say here column, and column plus 1. And obviously, yeah, we can also just remove the new line in case there is a random new line, although, as I said, I don't think it can happen, but who knows. Right, so here we just iterate over the columns in the current line. And what we need to do is check what character do we have on the map. So if we have a hash symbol, it's a wall. If we have a dot, it's empty. And if we have a 0, it's a box. And yeah, player, but or I guess robot. So let's get the current character, which is gonna be line.str of column. Okay, char ch. This is the character. And here we can do like if ch is equal to hash symbol, we are going to do something. If ch is equal to o, I think it's capital O. Let's just copy it. Yeah, it's oh, see, like maybe this is why this like using different fonts makes sense. You can see that in the font that I use. Yeah, I think it's like Yosefka or something. The 0 has a slash through it, so you can easily tell if it's a 0 or not. Okay, and the last case is if we have a dot. Oh, if we have a at symbol, sorry. So if we have a at symbol, that's the easiest one. Obviously, we just say puzzle robot is equal to vec2, and we just say column is column and row is row, not column. And it's by reference. Okay, so that's one part of it. And I guess would be easier. No, it's fine. We're gonna do it like this. So here we are gonna say walls, and we just need to pass here a new vec2 with column and row. It's a bit weird that I I think it's fine. I don't know why it shows it like that. Okay, and here it's boxes. So I think that's how we are gonna parse the, I mean, sure, we could just say vec2 position is equal to this stuff, just so it doesn't annoy me. And then Whoa, I didn't expect that. CI was, wait, did it surrounding? Okay, so it's a bit smaller. Okay, perfect. So I guess that's how we are gonna parse the input. Obviously the input cannot really fail, so I can say parse input, and we are gonna pass in the input slice, and we are gonna get the puzzle. Okay, and we can print something like percentage d puzzle dot robot dot puzzle dot robot dot color. So, oh shit, I need to import string slice as well. String slice. Right, so the robot initially is at 4 4, I guess. 0 1 2 3 4, yeah. Okay, that's fine. I mean, a cool trick we can use, hopefully this is something new you will see here, is when we print like if you want to print a char pointer and you want to print only a specific length of it, so let's say you want to print 10, like 2 characters from hello world, right? Let's say you do something like this. This is just gonna print he, or I guess didn't, because why? Okay, let's put it somewhere here, right? So that's the idea. Maybe let's print the lines. That's what I wanted to do. So if you put that's how you print a string slice. Basically, you use the length and the str, and it's gonna print the string slice. So let's see. Annoyingly, it does all of this stuff. Interesting. So maybe I can do something like this just to see what each line contains. Okay, nice. So if I put, that's a bit annoying because of the, let's use parentheses. Let's use parentheses, and there's maybe, okay, so it's empty actually. I guess it makes sense that it's an empty string. So here I guess I should actually say, instead of this stuff, if line length is equal to 0, then we break. But it's weird because, I mean, no, it's fine. Yeah, so see, it does only this part, and it parses, like that's how we print a string slice, right? Pretty cool. And then we get here the lines. Okay, perfect. So glad we did that, so we caught this small error. Anyway, that's the first part, like just parsing the input, which kind of sucks. I mean, I know I said that other languages, oh, it's hard to parse the input, but in C it's even harder. But maybe it's just because, you know, I know the language pretty well and it's easy, but it's also really straight. Like, you don't have complicated stuff. It's, I really want to do this one in Go. Maybe like I'll keep Go for another harder problem. And you'll see that in Go it's kind of similar because it's a really simple language, but it's also really straightforward, like what happens there. So I at least I hope, didn't really do a bunch of string processing in Go, so it's gonna be interesting. Anyway, so let's see how we are gonna solve this this one. So what what do we need for part one? So what do we need for part one? We're gonna return a number, obviously, and as input we get a puzzle. Let's just say puzzle. We're gonna get a puzzle as input. So we have total and return total. Perfect. So what do we have to do in part one is to just iterate all the moves, right? It's kind of straightforward. Let's say unsigned int I is 0, I is less than puzzle.moves.count. So we go until the end of the array and we do I++. Okay, so let's try to get a move. So how do we do that is with this dynamic array get. Yeah, we don't really have like accessors like in C++, so you just have to do what you have to do. So we just get a move index I, and we have to give it the reference to this thing. It's moves. Okay, and let me just add the error checking. So this is how we access an item in our dynamic array. Sure, whatever, would be easier to just use the classic arrays like this, but yeah. I mean, what you can also do, but that's a bit weird, would be puzzle moves items, but item is a void pointer, so you have to cast it. I mean, it works, but I like using this function better. Okay, anyway, so we got the move and we need to generate the next position. So let's do a static vec2 add. So this is gonna be an add function for our vec2 thingy. So let's say we get a vec2, or I guess this is a returns a vec2 position or I guess A and B, let's say, right? And we have a vec2 result is equal to 0. Oh, actually, let's just do it straight up. So it's just gonna be return, and a row is gonna be A row plus B row, and column is gonna be A column plus B column. Nice. So that's how we add these things. Great. So we can have something like next, and that's gonna be vec2 add, and we're gonna do puzzle this robot and the move. So we get the next position, the next potential position of the robot, right? So what we have to do in this case is to just check if it's going to be possible to move the robot there, right? So basically, if we have a wall in that location, we cannot do anything about it. It's GG. If we have an empty space, then we just move, and if we have a box, we have to do some special case. So let's say we have something like static bool. Yeah. I guess I can say part one has wall. Maybe it's you know, because yeah, so has wall, and in here I'm gonna do puzzle. Let's just send the entire puzzle and the coordinates, so vec2 position, and this thing is just gonna check if it has a wall in that position. So let's have a for loop over all the walls in our map. So we're gonna say walls, and we need something like this to iterate them. So we take the move. I guess this is like wall position. And let's have another function here which returns a boolean, and it's like vec2 equals, right? vec2b, and this is just return a row is equal to b row and a column is equal to b column. So that's that kind of makes sense. All right, so here if vec2 equals wall and position, then we return true because it has a wall, and at the end return false. So if part 1 has wall of puzzle and next position, so if we have a wall, then we cannot do anything about it, so we just continue, right? We just continue. Now if we have a box, that's gonna be more interesting. So has box, so we iterate the boxes, and we have a box here, and say box, nice. So if we have a box, part 1 has box, puzzle, and next we are going to do something else. We don't know yet what we are going to do. And on the last case, if it's an empty space, and I guess at the end we are also going to continue or something. Maybe it makes more sense to say else if and else, right? And if there is an empty space, then literally we just say puzzle robot is equal to next. So we just do that if it's an empty space. Okay, but now what should we do for the box case? Well, let's do a function static. I guess I want to return a boolean. I want to have a function called pushBox, and pushBox is just gonna do basically the exact same checks, but on top of that it's also gonna move the box if like it's gonna be a recursive function, and it should return something like, okay, this box was pushed. So you can do whatever you want with whoever called this function. I think that's how I want to do it. So let's say part 1 push box. Ideally it should return an array, so it returns an OK flag if the box can be pushed, and ideally it should return an array of let's say the box ID, or I guess the box index, and I guess like a box index, right? And it's a list of indices, so we know which boxes to push at the end, because maybe you want to call this function a different way, but yeah, whatever, let's not worry about that. So we are gonna pass in, obviously as usual, the puzzle, and this time it needs to be a pointer because we are gonna change it. I guess it doesn't matter because we are not gonna change we are gonna change the fields, so yeah, whatever, we are gonna do it as a pointer, why not? It should work without, because the data from the arrays is actually in the yeah, it's allocated, so it should work without. So we pass in the boxes because that's what we need. We need to pass in the direction and I think the next coordinate, because if we want to say that that's where the box, oh no, yeah, we want to pass in the box index. So let's say int box. So this is the box that we want to push, and obviously, yeah, the direction we want to push the box. And as I said, this one should return a boolean, and yeah, ideally we could do that. Let's try to do that actually. Let's try to have an array of indices for the boxes, right? So this should be a dynamic array for the result. Let's call it res. So maybe it makes more sense once we get into it. But what do we want to do here is find the box index. So I guess it's the same function twice, but that's okay. Has box, actually let's return an integer. So here we return I, and here we return -1. So we can just use hasBox as if box is greater than 0 or equal to 0 actually. Right, so we just get the box index because I'm too lazy to write the same function twice. But you can see it returns the index of the box if we find it. So I think that should do it. So what we are going to do here is part 1 push box puzzle box the direction, and here we need the reference to indices, let's say, right? And if this thing is true, then we have to do some stuff. This dynamic array indices 0 array init indices, and here is size of int because we have an array of integers. Okay, and we have to do some stuff here as well. Probably it's gonna be puzzle robot is equal to next. So looks like but on the else case we don't change that. So on the else case it didn't work. So yeah, but as I said, here we probably do this. So yeah, and then here we are gonna use the indices to do something. I guess maybe what are we gonna do? What are we gonna do? So we keep indices of the boxes that we want to push. I guess it's a bit stupid, but sure, why not? Let's do a for loop. I think we already use I, so let's use j. J is less than indices dot count j plus plus and vec2. I guess I can say I can do that. Unique array get, so we get the index of the box into something like reachable. So we get the index of the box, but that's not right, because this should be an int then. So I should have a int index, and that's what we get here. We get the index, and then we are gonna get from, oh, you know what, get ref. And I think get ref, okay, get ref also can fail. So here we get ref. This is more cool, so this is gonna be a pointer. We get the reference because we want to mutate it, so this is gonna be puzzle boxes. Index is index, the one that we got here, and the box is gonna be reference to box. I think here it complains that it wants to say void pointer. I think it's only void. No, I think I changed this one, or did I not? No, it's still void pointer for some reason, although it should be just pointer. Okay, so basically box is gonna be vec2 add of box and the move. All right, so this thing is gonna mutate the value from the array itself, so we don't have to assign it again. Right, so I think that's how we are gonna handle the indices. So this function is gonna give us the indices that we need to move in case it's true, otherwise it doesn't return anything, so we don't even worry about it. And in this for loop we are just updating those box positions and then the puzzle position as well. I think that should do it. And in this function then we have to do the same kind of logic as we did here. So in case we, yeah, what sucks is that we compute this next thing so many times, but it's fine. So we have the next position for the box, and I need to get a box. Let's just say something like this. So we need to do next. So this is a vec2 for the box. Puzzle boxes. Index is index is index, and box is box. It's a bit weird. Let me just double check this part. So here we have box index, just to be sure that we don't mess anything up. Okay, so this is gonna take in the index, we get the box, we apply the move on the box, and if we have a wall in that position, then this thing should be just false, right? Otherwise, if it's not a wall, we can do something like we did here to get the box index. So this is the box index for the next position, and if box index is greater than or equal to 0, then we have to do something else. And on the else case, we just return true, but we don't have to forget about let me just, so basically here we need to recursively call to, I guess I'm gonna do like return and recursively call to this function. Or what should I do? So we pass in the puzzle, box index, the move, and the pointer to result. So if that thing returns true, we need to do something extra. So I guess if this thing is true, then we need to return true, obviously. Otherwise return false. And on the last case we always return true. But before returning true we have to do something like ds dynamic array append in our result, and we need to append the box, like the index itself, this one, this index. So let's say index, right? We have to append the index, and we can expect the out of memory error, right? And on the last case we did the same thing. So we just do that part. I guess I could have like boolean okay is equal to true, and then okay is equal to this thing, and then if okay we append, and then we just return okay, right? Like we can do something like this as well. I think that's how push box is gonna work. Right, so if we have a box, then we have to check it. If it fails, then it failed. It is what it is. Okay, I think that's kind of it when I think about it. So we get the move from our moves. We get the move. Then we attempt to move the robot. If we cannot because it's a world, then we don't update its position. Then in case we have a box, we have to do some special logic. Otherwise, if it's just empty position, we just update the robot position and that's it. And in the special logic part, we initialize this array, that's fine. And then if we can push the box, right? If we can actually just push that box, we update the box positions and the robot positions. And I know I can do this one in the recursive call, but I want to keep it like the recursive call doesn't also modify the puzzle. It only says you can push the box or you cannot push the box. And then we get the list of indices. And this is more for if we want to print how it works, we can like do a better like demo of it, sort of say. So yeah. So here I'm just gonna say part 1, text in the puzzle, and this is int result 1. Okay, let's then, you know what, but I think that's like would be cool to have like but only if like for streaming would be like, okay, now let's do a poll and see who wins, like is it gonna run first try or not, who believes in the, I guess the doubters would have won, but that's just because I forgot to update the total. So maybe it's not all the hope is lost, right? That's what I want to say. So we didn't even do anything yet, right? With the total. So let's move the total, oops, down here. And now let's do a for loop over the boxes. That's what unassigned, what we had to do for the first part. We need to iterate the boxes, count I++, and I think I have like, okay, I can just reuse that this code right here. So we take the boxes, index I, and what do I have to do? It's total plus equal to box, not total plus box times, and here I think it says that you multiply the row with 100. So a row times 100 plus box column. Okay, so now the bet should be open. Wait, how did it make sense though? Like, is it really 0? That's crazy. Okay, let's start with the printf debugging, I guess. I mean, what else can we do? So we have some stuff that's interesting. What the fuck? Box row, box column. I mean, this is kind of weird. How is it 0? Shit. It's all 0. I mean, this is kind of cooked. Let's do another function that prints the puzzle. So it's gonna be puzzle dump. Let's do it here. Let's type here void puzzle dump. Shit, that's bad. I mean, why is it all 0? Maybe I forgot to initialize something. So let's print the boxes. So printf boxes, new line. Okay, and then let's print Woes. Damn, this kind of sucks. And last should be also the moves. Interesting. So move is actually just oh, I guess move is also a vector. Okay, interesting. So we print that, and the last thing should be the robot, which is gonna be just printf of puzzle robot row puzzle robot column. Okay, I mean it wouldn't be C. Okay, I forgot to. Let's not even run that. So puzzle dump. Shit. So the robot is fine. I think yeah, here should be Woes, and here it should be moves. So it's all zeros. That's funny. Whoopsie doopsie. Okay, why is everything 0? That's a good question. So when we parse the map, And yeah, I mean, that's a good question indeed. Why is all 0? Because I forgot to say puzzle init puzzle. Nice. So now we get something. So let's I mean 9007. Shit. I mean, it's close, but it's not right. Look, we have another puzzle input that's smaller. Maybe we can try to use TMP2, this one, which is smaller. Maybe that's better. So and it's like 1600. Okay, so it's always smaller. That's good. Can we maybe print each step? Can we maybe print each step somehow? I mean, that's kind of annoying to do, honestly. What's important though, like walls are not, we know that walls look good, right? So we don't really care about them. No, like maybe, yeah, maybe like just dumping the entire thing would make more sense. So then, as I said, width and height are gonna be part of the structure. Height, width and height. So when we parse the thing, the rows at the end are gonna be that, and the column here it's gonna be line length. So I'm gonna say something like puzzle height, no, puzzle width is equal to line length, right? And here at the end, puzzle height is equal to row. Okay, and let's move this one down here. And what I'm gonna do, something else as well. Has wall is also gonna be an integer, right? And here we return I, and here we return -1. So when we do has wall, it has to be greater or equal than 0. And it's also another one has wall here. I think those are the only two ones. Yeah, okay. So as box, yeah, it's fine. So what I'm gonna do then is for, we can do int I is equal, wait, let's do row is equal to 0, row is less than puzzle height, row plus plus. For int column we do the same thing, puzzle, but this time is gonna be width, and we have to do some stuff like int wall is equal to part1 has wall puzzle, and then I give it the vector, right? Vector call is call, row is row. I think, wait, okay, whatever. So this is gonna say if we have a, but I guess I can just say vector position is equal to that trash. So then position. but let's start with the easy ones. So vec2 equals position puzzle.robot. So if we have a robot, then we print f the at symbol. Then we do a wall, and if wall is greater or equal to 0, then we have vec2, or wait, yeah, no, if it's greater than 0, then we just print the hash symbol, right? I don't need the coordinate. The fuck. And here it's box. So if it's a box, then we print an O. And let me just do an else. And on the last else, we print f a dot. So it's empty. And print f a new line and another new line. So now we just print it as, yeah, okay, puzzle dump. So let's see what the puzzle looks like in the beginning, I want to say, but here I should do core plus plus. Oh, what? Huh. I have another printf somewhere random. Interesting, but why doesn't it show the boxes? So that's good, but I don't see the boxes, and that's weird. Oh. Whoopsie. Okay, so, yo, wait a second. It just worked. Holy shit. It just worked. I mean, no, it wasn't really like first try, but close. Pretty close, I would say. So if I do something like printing this, like doing puzzle dump here, let's move puzzle dump above part 1. We should be able to see the like frame by frame happening. But you know what would be even, I mean, it's way too fast, right? It's way too fast for us to like frame rate it, but no, it looks exactly like the output. Nice. So that's part 1, I guess. Day 15. That's part 1, I would say. We're closer to finding the chief. Oof, it's good. Oh my god. Oh my god, this looks so bad. Holy shit. Okay. The lanternfish use. Okay, so let's start with part 2. So the lanternfish use your information to find a safe moment to swim and turn off the malfunctioning robot. Makes sense. So just as they start preparing a festival in our honor, there is a second warehouse's robot that's malfunctioning. Who would have guessed? So, we have to convert the layout into another layout now. So if the tile is a hash, the new map contains 2 hashes instead. If the tile is an O, we have like brackets. A dot is 2 dots, and for the robot it's just the robot itself. Okay, this is twice as wide, obviously, and this will produce a new warehouse. Shit. Oh, interesting. So the boxes are twice as wide. So what I would say is let's just pretend that this is two boxes, right? And at the end, when we compute the total, we just take the left hand side. So it's the same problem, basically. We just have to, when we do the parsing, we have to do something a bit different, but it's going to be the same thing. So yeah, because the boxes are twice as wide. Oh no. Oh shit. There's also like if it pushes it from the bottom. Ew. Ew. Oh my god. No way. Shit. I think we are cooked, boys. I think this one's. I mean, it's not hard. Like, oh, I don't know an algorithm to solve it. It's just that it's so many like edge cases, and we have to code so many if statements that is gonna be annoying. Oof. Oof. I mean, yeah. Well, I guess then we just have to modify almost everything because my idea of okay, let's just pretend that each of these is a box doesn't really work because they need to like have a width. So when I do next position, yeah, it's like it is next position, but I mean, let's see. Let's try to do it. So then I guess instead of a single vector, we are gonna have two of them or something like that, or at least it's gonna be vec2 and an extra width, which we already know it's 2, but it just makes more sense. So we are gonna keep the same puzzle structure. That one makes sense. Parsing the moves is the same stuff, but maybe parsing the input is gonna be a bit different. So here we are gonna say, okay, it's still column, right? But shit. Mm-hmm. Yeah, I guess we can multiply everything with 2. We can multiply all the positions by 2 because it's just multiplying by 2, right? If you think about it. But just the x coordinates, the y coordinate stays the same. So if you look at this one, you can see that so here it's 0 1 2 3, and now it's 0 1 2 3 4 5 6, right? And this one is at 8. So we can just multiply the x coordinates by 2, and we just solve the issue of doing the map. That's quite easy, so we don't have to change this part. That's safe. So we just multiply the x coordinates by 2, right? And then we have to think about the moving algorithm, so how moving works. So let's see. So for part 2, let's have a function. for part 2. So first thing that we're gonna do in part 2 is have this for loop over the boxes, right? We take a ref of a box, we take the reference, and we have to, delete void pointer pointer, obviously. Probably my mistake, I should have done just pointer, but it is what it is now. And I have to say that box X, or I guess is the column, right? The column is gonna be multiplied by 2. Wait. No, what the fuck am I doing? Yeah. So I multiply the column by 2 for the boxes. For the walls, right, let's not forget to change the iterator like last time. So we take the wall and multiply its x coordinate. Wall, right? And the last thing we have to do is say a robot, or I guess puzzle robot dot column multiplied by 2. So yeah, and that's how we get the new coordinates, right? So maybe the last thing is puzzle dot width is multiplied by 2 as well. So now if we try to print, so if I do puzzle dump of puzzle, we should maybe see the result. Maybe we are gonna see something like it's wider, right? But you can see a small thing is that for walls we have to insert the other wall as well. Okay, makes sense. Let's insert the other wall as well. Right, so I think yes. So I'm gonna do something. I mean, it's a bit weird. So yeah, for walls it makes sense, but I cannot do it like this. I have to say int I is equal to count minus 1. I has to be greater or equal to 0, and we do I minus minus. Alright, we have to go the reverse direction if we want to append to the array. So what I'm gonna do is have a vector clone for the wall, and this is gonna be basically vector. The column is wall column plus 1, and the row is wall row. Right, but I mean it's a pointer, so expect to be able to dynamic array append, and we want to append to puzzle walls. We want to append the clone. Okay, I mean, yeah, it's expect, and here it's out of memory error. Okay, So now we should see it's a bit thicker. I mean, this is another example, right? Even another example. So this is the larger example from above. Wait, which one? I don't think it's this one. I think it's the other one. I think it's TMP1. So TMP1 would look something like this. Yeah. Okay. So we have even a third example then, like this one, which we can use. Again, TMP3. So let's use this one. Wait, why does it look like that? The fuck? Something looks off. Wait, I didn't paste proper thing? No, I did, but why does it look like that? The fuck? Excuse me? Like, why is this one here? Puzzle dump. Row column. Has box. What the fuck? Wait, what? That looks so strange. I multiplied the box's column by 2. What if I don't do anything to it? Wait, why does it look like that though? Oh, is it really? I guess, oh I think it's changing like part 1 is affecting the, yeah, it does. So I have to make a clone of the things. Okay, fair enough, doesn't matter. So yeah, it works, right? It parses it properly. Now maybe the only thing I want to do is have a puzzle dump 2. So let's go to part 2, have a puzzle dump 2, and here if it's the right position we print this stuff, right? Oh, we print with puzzle dump 2, and here the other condition is something like else if, I guess, if the column is greater than 0 and part 1 has box puzzle. Let's do prev printf the closing one, right? So prev is gonna be column -1. All right, so if I do that, it's gonna look nice, right? Okay, so what should we do for part 2 then? So it has to be a similar algorithm, right? So we have to do a for loop over all the moves. Let's just copy the entire thing and try to figure it out. Right, we're gonna copy the entire thing and we're gonna try to figure this one out. So we get the move, right? If there's a wall we cannot move, then that's fine. If we find a box in the next position, and now this is interesting. Next position has a box when there's a so for both no so the next position has a box if next or next minus one have a box, right? So that's the thing. So if next is right on top of a box, then that's fine. Then it means there is a box. That's the normal case, right? But if next minus one also has a box, like the same box, probably. So I can do something like if box index is less than 0, then we can say box like vec2 next offset is gonna be like vec2 row is the same as next row, but column is equal to next column minus 1, I guess. And box index should maybe be next offset. So if I think about it, it's like, okay, we want to move up, for instance, or we want to move left, or even right, or even down. And we take a look at the next position. Is there a box? Yeah, I mean, there is a box. So then we are good. We don't have to do anything extra. It works like before. But if there is not a box there, we need to check. So we might be looking at the closing bracket. So we might need to check the left side of that position. So I guess let's call it next left. So the left side of that position, which is column minus 1. And if there is a box, then also here there was a box. So we update box index. So if box index is greater than 0, then we have to initialize these indices. We start to push a box, but this one is for part 2. We don't know yet how it works. Part 2 push box. And I mean part 1 has box, could be actually part 2 has box as well, and it does this one automatically. So yeah, let's go to part 1 has box. Let's go to part 2. Let's go to part 2. I mean, doesn't matter. Part 1 has box. It's gonna do, so if they are equal, but on the last case we have to say something like oops, this thing. So we get to this new position with color -1, so position left, and what we have to do is the same for loop, position left, and here it's position left, right? So that's gonna do it. So we get the box index for part 2, and then we have, if it's greater than 0, we have a box there, we put the index, we try to push the boxes, and I mean, then we literally push them. We literally push them, and the robot gets the next position. Okay, so I have to implement this part 2 push box. Part 2 push box. Let's just invoke some, I don't know, like manifest saying that, oh, this is gonna be so hard, and it's actually gonna be easy. So we get the box, we add a move. If there is a wall there, ooh, interesting. So if there's a wall at the next position, so wait, box is gonna be the start position. So if we have a wall at the next position, vec to next right, so this is the closing bracket, so to speak. So vec2 row is gonna be next row, column is next column +1, and this is gonna be the right position. So if we have a wall, part 1 has wall puzzle on the left or on the right, then it's over. We cannot push it. Okay, but if we somehow have a box, and this one is interesting because we can have 2 boxes. So let's think about it. So we have a box index on so this is the left side of our box. We can even say that next to left. So this is the left side of the box, and this is the right side of the box. If the left side of the box has an index, all right, it means that we are pushing that box. Okay, so let's call it left. So if there is a box on the left side, we try to push it. We are trying to push it. Right. You know what? What if you, like, if you push from the right side, then it might want to push itself, which is kind of weird. So I might have to say and index is not index. You know what I mean? So and the box index left is not equal to index, because if you push from the left side to the right, then it pushes in itself somehow. I know it's weird, but it can happen. It's pushing itself. So I think that only happens there. I don't think it can happen here. So it's like, yeah, it doesn't matter. So this one here, right? If you are pushing towards the right side, then the left side's right is going to be itself. So we have to say it's different than index. Okay, and then the other case. So I guess here it's like, if okay, then we do the other case, otherwise it doesn't even matter to do it because we cannot push it anyway. But let's just do that. So right, and if we are trying to push to the right, the box index right, and it has a box there, then we have to also push that one. So it's kind of the same if, in my opinion, all right. But an extra thing is, and box index left is not equal to box index right, because there's no point in pushing it again. We already did. Right, and then we push part2 push box, part2 push box with index right. We push that one in the same direction, and then if okay, we append the index, otherwise we say it's false. So let's do, this is part1, so we puzzle dump it here. Let's puzzle dump it at the end as well, and let's see what happens. Well, I mean, it was it was bound to happen. It was bound to happen. At some point, segmentation 14C, it's like, do you even see at that point? Okay, so where did the oopsie doopsie happen? That's the interesting point. Let's see what this box index is. Let's just see. It's 1, so it's the first box, I guess. At least we get something. Okay, and what happens when we do push box? What happens when we do push box? So we are gonna call to push box. Shit. Box index is 1. We have the move. Like, where does the segmentation fault happen? That's an interesting point. So let's say we print next left column. Let's just see, 5 5 5 5. So it literally pushes, oh shit, it literally pushes itself somehow. So it's segmentation force because it's recursive. So I still didn't manage to save it from recursing, like going into recursion on itself. Shit, let's see here what the index and the box index left is, and then maybe here as well, but for the right. So I might say right, left. So right pushes that, left pushes. Okay, so it's -1, but it's interesting. If it's -1, shit, then okay, it's true. So here I have to say okay. No, I guess it's fine. Okay is right? So here it's 0, 0. So it doesn't go into this one. Right, it doesn't go here. Okay, how the fuck? So box index right is greater than 0. Ah, shit, here it's right. Okay, okay, okay. Whoa, 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 okay, okay, it looks kind of right. What the fuck? Wait. Wait a second. Let's run it on the big one, on TMP1. Yo! There's no way it actually works. There's no way this piece of trash actually works. Imagine, like if this was like, you know, a bet, and like how many doubters there, like there would probably be only one person that would say, okay, I believe it's gonna work, and imagine how much they would win on this bet. Whew, insane amounts. Yeah, I mean, that would be, let's see, let's just remove the dumps because it's gonna take too much time, and let's do this stuff. Let's see. So 9021 looks, the map look good, this map look good, so now this is bad. I mean, imagine the excitement of the guy that would bet, you know, that it was first time he saw that this worked, and other guys would be, oh my god, we lost, and then that happened. Okay, fuck. So it's too small. I guess that's really bad because it works on shit. Like, there's no way I can look at this stuff and figure out what happened. God damn it. I try to figure out what went wrong. Okay, what edge case did we miss? Did this one look good? Because I think it did. Yeah, it actually did. It looks fine. Okay, what about TMP2? I mean, it's literally way too hard to be able to tell, honestly. So that's where we started, then it went up, then it went left, it pushed it left again, down, down, right, down, right, right, down. I mean, it doesn't make any sense because this one looks exactly the same. It's the same stuff. Shit. Like, what edge case did we miss? What edge case? We could even do our own map. Like, I want to see what happens if I do like move in that direction or something. TMP3. Wait, what the fuck? I thought I... Oh, I modified, yeah, fine. So it goes once and twice. So this thing is pushed fine. Right? Yeah, it's all good. And let's say then we go down once. That looks good. Mm-hmm. Right. Right. So what if, I don't know, like I add an extra one and I say that we have a thingy there. I mean, it makes sense, they are not overlapping, but yeah. Which one did I miss? The fuck? Which edge case? There's no way we can figure that one out, sadly. Like pushing from the right direction to the left was fine. Okay. Because this example looks quite complicated, so yeah, I mean, I don't know. Wait, let's move my guy here. So I want to push it once. No, I want to go twice to the right, bam bam. Then one up, one. Let's just do it piece by piece. So I want to do that. Then I want to move to the right once and then down. What is this gonna do? So it actually worked as I expected. What if I go down again? Maybe it pushes the thing stupid? No. Let's go around it. Oh, I mean, you know what would be cool? To make it interactive. Like I press the move keys and I move the character on the map. Alright, so that way we can easily test a bunch of trash, but I mean, it would take so long, like it's already turning into, yeah, like making it to work like interactive would make sense, I guess, but just to test different things, but I don't know. Like we can copy paste part 2 and say something like part 2 interactive, and here instead of doing the for loop we can actually have a while 1, and instead of getting the move like that we can actually read a character, so we can do something like c get char. No, like I had a like the Tetris in C, I implemented something like that. So in the CLI version I should have some way of actually reading the input. So it was this TTY cooked thing. So I can say something like we run system stty cooked, we clear the screen, we do that, but how was I reading the input? Let me just put this one here. How was I reading the input though? How was I reading the input? So it was just get char. Let me just put it here. Char get char. And I guess I have to, let's use WSD because otherwise it's gonna be really cooked. So I'm gonna say here parse move, but it's WSD based. So if it's A, D, oops, WSD, so we parse it, parse WSD, input. So that's how I would generate this thing. So I would generate it. What the fuck is that? Okay, anyway, so we dump the puzzle. I would dump it here actually. No. So we read the move and then we print it at the end. So I should in fact just print it here and wait for the move, and I don't print it here. So now if I say down here part 2 interactive, shit, what? Let's not do the hooked thingy. Let's just do get char and see what happens. But get char, what? Not the move, percentage C. Or I guess I'll do percentage D just so I know what was inputted there. -1. Wait, what? Read the char. It's because I'm fuck. Yeah, I know why it happens. It's because I do DSIO read. And it reads an end of file character. Shit. How can I combine them then? See, reopen std in after I don't know, recover std in from end of file. Interesting. I mean, on get character to push back a character can clear the end of file indicator for a stream. So we can try to do something like this. Let's see if that works. Otherwise, I'm just gonna hard code the puzzle into the thing. So if I run this thing, no, it doesn't want to work. Shit. Then I guess I can just say tmp3 and it's just gonna read the file, so I don't have to tell it anything. So if I go up, wait, I have to only say, oh wait, that's annoying. Maybe I need to make it cooked, right? Or was it raw and then cooked? I think maybe that's it. But now we are on so this kind of works, right? So we can kind of test different configurations, see what, like which one made it go boom. So maybe I can also clear the screen after we read the character. Oh, and maybe even better is if we read this one, the big TMP, because this is a bigger file. So what what went wrong? Let's put something like this. Like, let's see, if I push this one from here, it doesn't do anything, that's good. If I push this one out of the way and I push this one here, it pushes everything, so it's literally just working. What the fuck? And I'm not sure why it didn't work there. I mean, I can see that kind of all of them work. So what? Huh. I'm curious, what's the edge case? It looks like a weird combination of them. If I push this one, if I go here and push this one, oh, I locked them. Shit. Yeah, like it's weird. Yo, that one broke it. You saw that? So I pushed, we have like a rhombus shape, and I pushed it and that one pushed twice. Oh, we found the bug. We found the bug. Oh my god, that was such a that like yeah, I understand why the bug happened. So if we go to part 2, oh my god, the bug happened because of dumbass. So, but I'm gonna leave this part because it's fun. It's like a mini game. Oh my god, but yeah, the bug. So why does the bug happen, right? Let's see. So when I lost that. So when we push one box, right, it branches on two cases. It goes on the left side and on the right side. But what if after some time the branches come back together and both of them push one box? Well, we are gonna append the same index twice here. So we need to make sure that the indices from here are unique. So how are we gonna do that? Let's go into the puzzle. So here after we get the indices, right, we need to make sure that the indices are unique. So we need to make sure that they weren't pushed before. So I'm gonna make, let's, do I have a DS dynamic? No, I cannot have that. Let's do like unique. Static void DS int unique DS dynamic array. So this is an array of integers, by the way. So yeah. So what I'm gonna do is have a dynamic array. So it has to be a pointer, I think. Fuck. It has to be a pointer, I think. What the fuck am I doing with this? I think I was pressing U by mistake. So this is the set. I'm gonna use a hash map. I guess a hash set, imaginary hash set. So this dynamic array init. Let's pass in the set and size of init. Yeah, that was an interesting one to see. Okay. I guess. Nah. Let's just keep it even simpler. So I'm gonna do the thing here, right? And I'm gonna say something like if ds dynamic, but I don't have contains, right? But we are gonna implement it for this one. If the dynamic array contains, so which dynamic array? The set one contains index, then we continue, right? Because we don't want to actually push it. We don't want to push the box because we already pushed it. Right, and at the end here we want to dynamic array append into set. We want to append the index. So we just have to implement dynamic array contains now. So dynamic array contains, so this contains, we get an array of integers and index. Is that all? I mean, why not? So this should be bool. So here let's make unsigned int y. Yeah, but that was a hard one to find in the end, if you think about it. Int item 0 unreachable is gonna be ds dynamic array get. We pass in the array and index I, right, and also reference to item. So I'm gonna say something like if item is equal to index, then we return true, otherwise we return false. Right, so now this one should actually fix the problem. So what I can do in the infinite one, let's say, is just copy this part. Or I guess let's just copy the entire if. The if else, because I don't remember, like I have to change this entire if else basically in the interactive one. So let's test again. Alright, so if I like trying to simulate that, right? So I'm pushing that. Let's start again. So how did I build that thing? I think I know how to do that. So I'm gonna push this one here. I'm gonna go here and push this one like this one like this. Let's push this one out of the way. Now if I push this one up once, it should only push it once. Nice. Let's push this one out of the way. I mean, we could try to build a bigger one, but I'm pretty sure that was the issue. As I said, we can try to build a, oh shit, a bigger one. Oh, fuck. Like, oh no, yeah, it was fine. So a bigger one would be something like this, I guess. This one, oh, this one is the biggest one yet. So if I push it once up, it should move perfectly, yeah. Nice. So imagine that if I didn't do that check, they would be like insanely moved. Okay, so it means that we can just change this one to null. Yeah, I have to figure out how I can make it oh, TMP 3. So TMP 3, it's a different one. This one still works, so that's a good sign. Oh. Let's remove the puzzle dumps because they are not useful. So it's this much, which is a different number. Let's see if it's right. And we actually, that was such an annoying edge case, but feels nice to actually get it. Okay, so yeah, that was, I mean, obviously it's a pretty cool day because we are able to like have that mini game working, which is pretty nice. But yeah, as I said, I want to kind of leave it, but I get this news result. What does it return? I don't know. I think it's an int. Oh, let's do one. No, let's just do int equals. So find yes unreachable. I think it returns 0. Hopefully, like I. Oh, you know what? It'd be maybe even cooler to try to run. Let's do again on TMP, just to make sure that okay, anyway, I can have like int result is equal to 0 just to make it shut up, I guess. Okay, so let's just remove this one and give it TMP. Right, so now it shuts up about that error. Perfect. So the only problem we have now is, oh, I still have interactive. The only problem we have now is that we modify the thing. So I might have to do parse input twice just to get rid of that problem. Whoa, what the fuck? And the other one is to puzzle init it again. I mean, I know it's memory leaking, but who cares? Okay, so yeah, we actually got the expected result. Nice. Yeah, I mean, I could make a separate main for the interactive one, if you want to, if you'd like to play with it, but yeah, we'll see. The only thing I'm not really happy about is I don't want to specify the file, so I want you to be able to pass in null here and do the reading, and then this somehow, if we are able to reset get char to not return -1. Oh yeah, that's the only thing. Okay, yeah, I mean that's kind of it. I would like to also have the makefile. Makefile, for instance, 01 makefile is a good one to always copy. So it's clang, and we do clang main.c, maybe dash or main, but yeah, that should actually be everything, and we should just get an executable, and that's it, right? With the makefile. And yeah, also git ignore would be helpful. Git ignore is the makefile. Right, and now I can put inside of the Nix flake, I can actually just let's say copy paste day 1, and we'll have day 15 as a Nix command or something like that. Right, so we have day 15 without that part, and I mean just maybe packages.clang, like that's the only thing that we need. Alright, and that's gonna give us, what color is next? I think yellow wasn't used in a while, so let's put it here. It's day 15. Okay, in C. Nice. I mean, it was C plus my, I know I said without external dependencies, but that's still written by me, so does it count as external dependency? I don't know. Mix run. So let's see, if we run the entire AoC script, it should run all the 15 days. So still prologue is the slowest one. I really like that. I don't think, maybe there is another one that's a bit slow. I think, oh, yeah, I'm in JavaScript. It's weird because I rewritten it in for some other reason, and it's actually faster than that, like much faster. That's a bit weird. Yeah, so we actually get, all the days, each with its own language. So we did C3, C++. I mean, obviously now that I compare it, C3 much easier to work than C, even with my ds.h. It's a bit difficult, but come on, like C, like you cannot, 500 lines. It's like such a simple language that it's really easy to follow, I would say. So yeah, but that's that's it for today. We managed to get both parts. Second one was a bit more tricky, but it wasn't like how to say it, like you have to solve a problem in O of n instead of O of n squared, right? It was just like grinding the problem, grinding for the result. So yeah, I mean, all in all, it was pretty fun because we did that simulation, so that's quite fun. So yeah, that's all for day 15. So yeah, hopefully we'll see tomorrow with the next day, and I'll have to check what other languages we can use. Like, obviously I want to keep Golang for a hard day, and also Python, like maybe TypeScript. Even though we did JavaScript, TypeScript is a different language, so I can cheat with that. But yeah, let's see in the next one. So see you.